So we are going to translate along vector v. Vector v, we start here, it goes down 2, and to the right 1, 2, 3, 4, 5, 6, 7. Down 2 and right 7. So that's what we're going to do with every point. Down 2 and right 7. Down 2 and right 7. Down 2, right 7. So that's M prime, N prime, and P prime. And we can write in the coordinates. M prime is at 1, 4. N prime is at 6, 0. And P prime is at 0, negative 1. Triangle XYZ has these vertices, so let's go ahead and draw it first. 1, negative 1, that's point X. 0, 2 is point Y. And 3, 1 is Z. So now we are going to use the rule X plus 1, Y minus 7. That's the same thing as going right 1 and down 7. Or you could just get the coordinates by adding 1 and subtracting 7. So if you add 1, you get 2. Subtract 7, negative 1 minus 7 is negative 8. To the Y point, we add 1, so we get 1. Subtract 7, 2 minus 7, you get negative 5. And Z, we add 1, so we get 4, comma, subtract 7, 1 minus 7 is negative 6, and we can plot those points now. Put 2, negative 8. That's X prime. Y is 1, negative 5. 1, negative 5. That's Y prime. And Z prime is 4, negative 6. So there's X prime, Y prime, and Z prime. Now we're going to reflect each of those points that we just came up with over Y equals 0, which is the X axis. So the rule for that is negative XY goes to over the X axis, so XY goes to X negative Y. So our X coordinate stays exactly the same. The Y coordinate just changes signs. So negative 8 becomes positive 8. The X coordinate stays the same. And the Y coordinate changes signs. So negative 5 turns positive 5. For Z double prime, X coordinate stays the same. The Y coordinate changes signs to positive 6. And we can graph those points, and then we will be done. So 2, 8. That's X double prime. 1, 5. That's y double prime. And then 4, 6. That is z double prime. And draw the triangle. So now we'll reflect this rectangle over the line x equals 0. X equals 0 is the vertical line, which is the y-axis. So it's the same as the y-axis. And then we're going to shift it along the vector 4, -1, and write the coordinates of E after each transformation. So first, reflect it over the y-axis, which is x equals 0. So reflect it. E is going to go here, F, T, and L. So it says to write the coordinates of E after each transformation. So E prime, that's 1, -1. Then we are going to shift it along the vector 4, -1. So that means we're going to shift everything to the right 4 and down 1. Now, to the right 4, 1, 2, 3, 4. We go a little bit off, but that's okay. Down 1, that's L double prime. T, we go right 4. Down 1, that's T double prime. E, right 4. Down 1, that's E double prime. And F, right 4, down 1, F double prime. And we need to write the coordinates of E double prime now. That is 5, -2. So with the following transformations, map the triangle onto itself, draw each image after each transformation, and so we're going to have a lot of triangles on the graph. So first, we're going to translate it -8, -2. So everything moves left 8, down 2. That is a left 8, down 2. That's B prime. And that is C prime. Now we'll reflect the triangle about the line y equals 0. That is the x-axis. So C is going to reflect up to there. B reflects down, 1, 2, 3 away, so B reflects down, and A also reflects down. So now rotate the figure 180 degrees about its right angle vertex. So if you rotate it 180 around the right angle, B is going to stay put. So that's B triple prime. C, instead of being up, would be down below because you rotate it 180 degrees. 1, 2, 3. So it's 4 away. It's going to be 4 away when we reflect it down or rotate it down also. And if you rotate this, A, instead of being on the left, we go to the right 3 units. That would be A triple prime. And you can draw that in there. So next we're going to reflect the triangle about the line x equals 0, which is the y-axis. So we're going to reflect it over the y-axis. A is already touching the y-axis. It's not going to move. B is going to reflect 3 units. And then C is also 3 units away, so C will be 3 units away. Draw your triangle. And then translate the figure according to the vector 2, 5. So we're going right 2, up 5. Right 2, up 5. And draw the triangle. So the question asked, did it map onto itself? Almost. It had to go 3 more units up than it would have. So it did not map onto itself though. Which of the following has an angle of rotational symmetry of 180 degrees? That means if you turned it upside down, rotated 180 degrees, it would look the exact same. That's only the letter H. Which of the following will not map the regular hexagon onto itself? Reflecting over X will not map, so that is true, it will not map it. Rotating 120 degrees, to figure out how many degrees, you would look at all the vertices. There's 6. You take 360 divided by 6 is 60. So that means 60 degrees, 120, 180, 240, 300. All of those will map onto itself. So rotating 120 degrees will map onto itself. 90 degrees will not map onto itself. Reflecting across Y will map onto itself. So 1 and 3 are the two that do not map onto itself. Determine the sequence of transformations that maps it onto from the solid onto the dashed. So first, that looks like a reflection. If you reflect it over the x-axis, we'll end up right there on those vertices. So then we just have to shift it to the left, translate to the left, 1, 2, 3, 4. You can write that as a vector, -4, 0. Rotate 90 degrees counterclockwise. That's the rule. XY goes to -y, x. And that's what's going to happen to all these coordinates. So it'd be -5, 2. -1, 2. And -1, 6.